Welcome to Lego Academy. Now, in this video, we are going to tackle a question in physics under half-life. And here the statement says, a radioactive substance has a mass of 100 grams and a half-life of 2 minutes. How much of this substance, so number A, remains undecayed, B, decayed after 6 minutes? So if we collect the data for this question, so here we've been given the initial mass, which is 100 grams. So initial mass, so the activity before this is 100 grams. And the question says, how much of the substance remains undecayed? So the substance that remains undecayed is the activity after. So the mass that remains after it has decayed, that is the activity after. Here in the question again, we've been given the half-life. So half-life, this is 2 minutes. And also the period, so the period, this is 6 minutes. Now, how can we calculate for that which is going to remain undecayed? So, this is the formula that we're going to apply. Activity before over activity after is equal to 2 to the power n. Now, with the data that we have here, we don't have n. So, n represents the number of disintegration. So to find the number of disintegration, we are going to apply this formula. For half-life is equal to period over the number of disintegration. So to make n the subject of the formula, we cross multiply. So this h multiplied by n, this is hn is equal to t. We then divide by h, even here h. So this and that, they'll cancel. So here we are going to remain with n is equal to the period. So if we check the period, this is 6 minutes. So the period, this is 6, divided by the half-life. So the half-life, this is 2. Now this 2 into 6, it is going to give us 3. So 3 is the number of disintegration. The number of times this mass is going to break. So the activity before this is 100 divided by the activity after, which is the one we are calculating for. So this is equal to 2, and here on n we are going to put this 3. So 100 over a is equal to now 2 to the power 3. This means that we have to multiply this 2 3 times, and this is going to give us 8. So to make a the subject of the formula, here over 1, we then cross multiply. So a multiplied by 8, this is 8a, is equal to 100. We then divide both sides by 8 to make a the subject of the formula. This and this, they'll cancel. Therefore, so a is equal to, so if we divide this 8 into 100, so 100 divided by 8, this is going to be 12.5. So this is 12.5 grams. So this is the mass that is going to remain undecayed. So for the last question here, how much of this substance decayed after 6 minutes? Now, how can we handle this kind of a question? So this is number A. So for number B, so for number A, we know that this is 12.5 grams. Now for number B, to calculate for number B, to know that which is going to be decayed after this period, since the initial mass, this is 100 grams, and we know that which is undecayed to be 12.5 grams. To know that which is going to decay, we are going to subtract this. So this is going to be minus 12.5 grams. So 100 minus 12.5 grams. So if we subtract 12.5 grams from this 100, we are going to remain with 87.5. So this is 87.5 grams. So this is the mass that is going to decay after this period here. So this is how we handle questions under half-life.